So, hi. My name is Stefan Rotsch. I'm from Wiesbaden, Germany. I'm very happy to be here the third time on this amazing little conference. And I'd like to tell you some things we learned about a couple of Agile programming practices, or to give it a more nice sounding name, I'll tell you tales from 1001 code reviews, which is actually not true. It is from 1092 code reviews, but the other one sounded maybe a bit better. And yeah, I also know that I'm responsible for getting us to lunch on time, so we will get this done in time. About me. I'm a software developer. I love taking photographs. I play the pipe organ, and I have two wonderful kids, and I'm working at AOE in Wiesbaden, in Germany. Let's Agile programming practices. When you read literature about extreme programming, you will find that 12 habits or practices, or however you want to name them, that are the foundation of this extreme programming approach. And today we will focus on two of them. Regarding fine-scale feedback, we will look at pair programming, and this also incorporates a bit of test-driven or test-first development when doing that in a certain manner. And we will look at the shared understanding of our project, namely on coding standards, collective code ownership, and also a bit of trying to keep the design simple, all these under the hood of code review. So with doing code reviews, we would like to achieve these practices. Let's get started. Take a look at pair programming. Who of you does pair programming when developing software in a regular way? Hands up. Who does not? I'll try to convince you, and maybe afterwards you can tell me if you want to give it a try. So benefits of pair programming. Why should you do that? Pair programming will increase code quality. Code developed by pairs, there are multiple studies proving this, so this is not only like theory, there are academic studies that took measurements. It does significantly reduce number of defects in code, and also developers working together feel a higher confidence in the code because they already have to openly think about the process that's going on while writing software. So by always having to explain to a different person what you are thinking and what you are trying to achieve, this will make you more confident that the solution you are implementing or delivering is maybe the best solution you can come up with now. Pair programming for sure eases team building and communication. You sit together, so you are a small team already, not everyone working focused with headphones on his head. You have a constant sharing of knowledge that even increases if you mix the pairs, so not always the same two people code together, but in the team you are rotating the pairs. So you have a constant sharing of knowledge and also transfer of skills. You might have people with various skill sets or skill levels in certain areas, and by pairing maybe a novice and an expert, you will transfer knowledge and even out the skill level of your developers. And it's also proven that a pair has an improved resiliency against disruptions. If you are working alone, even with headphones on, last year I gave the talk about productivity, that was one aspect of that talk. People come to you and say like, may I disturb you? The moment I had to put down my headphone and answer him, I was already disturbed. So yeah, please go ahead. And if you have a pair working focused together, people don't tend to interrupt them that often than individuals. Yeah, if you put 2 developers on solving a problem that theoretically one could also solve, you are asking an economic question, like how much more overhead do I have by pairing people? And theoretically, this could be like from 15 to 100%, because in the worst case, the second developer is only sitting next to the other and checking Twitter or whatever. So you might have a loss there, but in general and in multiple studies, it has been proven that the average overhead is 15%. On the other hand, it has also been proven that code developed by pairs produces 15% fewer defects. So from a mathematical perspective, this evens out. So there is at least no strong arguments against trying pair programming. This is just like you have to convince your management or your chief financial officer that this is worth a try, because it's not only like the cost for putting 2 developers on solving one problem, it's also the benefit of getting a faster solution, maybe with fewer defects that cause additional cost later when you need to refactor or fix the bugs. There are multiple patterns how to do pair programming. I would like to introduce 2 of them to you. The first one is the driver navigator pattern, as in a car, where you and your significant other sit next to each other, and one drives the car and the other one holds the map and knows everything better. Hey, look, the traffic light is green, yeah. So the driver is focused on tactics, on driving the car. The driver is focused on writing clean code, on writing code that compiles and runs, so code without obvious errors. And the driver is responsible for making the automated tests pass. The navigator is focused on strategy, like how to implement a solution, what to test, what test cases to write, and what to refactor. So the driver is the one at the keyboard coding, and the navigator is the one following in his mind and going ahead the route, like where do we have to stop next, and where do we have to turn, or when do we have to switch to another road. And this is like what has to happen in the mind of the navigator. And the navigator tells the driver what to implement, but the driver is responsible for the actual implementation. The other pattern is sort of ping pong, where developer 1 writes a unit test that fails because the logic is not implemented yet, passes the keyboard to another developer, and the second developer writes the code to make the test pass, writes another unit test to move forward, and passes the keyboard back to the first developer. This makes the first test pass again and starts over with writing the next test. So you have that ping-pong cycle of writing a failing unit test, implementing the code to make the test green, and starting over. And while doing that, shifting the keyboard around in the pair. Did I confuse you? Okay. Yeah, best practices. It has been proven that it is important to switch the rows frequently. We have people in our team doing this every 5 minutes. They have a timer, and every 5 minutes they switch roles. Because otherwise you would run into this watch the master phenomenon. So the master is the driver and codes, and the novice, or the not so skilled developer, is sitting next to him and has to look at what's happening. And this has a risk that the navigator might not be actively engaged. In some study I have read, he might even fall asleep. I have never seen that happen, but at least you tend to open your email application or whatever while the master is implementing the solution. So it is important that you switch roles on a regular basis, and this is the fairest way to do this is with a timer. Like your 5 minutes, my 5 minutes. This will also help to balance the differences in skill level. You have to keep talking. Pair programming is about talking to each other, about explaining your thoughts, about explaining your idea, where to go now, how to do this, and to be in a discussion and in a dialogue about how to implement your solution. And best practice also create a parent-friendly environment. In our office, every desk has 2 chairs, like one regular, a convenient desk chair and one spare chair, so you can easily come together and pair up. If you only have a small desk that is a mess, full of empty Red Bull cups, we also have this in the office for some guys, and no additional chairs, there is no opportunity for pairing up. So you have to make sure the atmosphere in the office is also pairing friendly. But wait, what about remote pair programming? If you have a remote team, does this work too? Yeah, it does. We also practice this in one project. The tool you want to choose depends on which pattern you are using. For the driver Navigator pattern, it might be sufficient to have a tool that only does screen sharing and audio. So the Navigator can see what the driver is doing. He don't have to interact and can discuss. Important is that you have a decent quality of screen, because when looking at code, usually you have your IDE at a certain size on a large monitor, and if the other one sees a scaled down image, it's barely to read any line of code. So this is why I put Skype as an example. This works pretty well. We also tried Google Hangouts, which has a pretty low quality and heavily compresses the image, and there it is really difficult. So you might try to evaluate different tools. For the ping pong pattern, it's important that you can quickly shift around and maybe both have access to the keyboard and the mouse to navigate in the code. And there we tried a tool named Screen Hero. This works pretty well. It has a decent video quality and also allows for both to input on the keyboard and use the mouse at the same time, and also supports audio calling. There are other tools out there in the wild, just like pick a tool that suits the job or the pattern you are trying to implement. And what I also found out, when doing pair programming excessively, like for 6 hours a day or so, I'm completely screwed up when I leave the office. Because this process of always being involved, always having to explain what you are doing, always being in discussion and in touch with a second human close to you, that's really exhausting for me. So when working alone, you can decide, like, now I need a break, now I want to check Twitter, now I want to grab a cup of coffee. When you are pairing up, you have to respect your partner and have to see and have to find breaks together maybe. And for me, this feels exhausting. So this code matches it pretty well. The adjustment period from solo programming to collaborative programming was like eating a hot pepper. The first time you try it, you may not like it because you are not used to it. However, the more you eat it, the more you like it. And I think that's the same with pair programming. Try it, jump into the cold pool of water and see if it works for you. And if it does, I think if you like it, you never want to work in a different way again. Code reviews. Why? My intention was originally to talk about code reviews, but why did I do the pair programming beforehand? A guy called Brandon Savage found out that developers should pair program often with others to learn their coding habits and style. Why? Because in a review, if someone gives a comment to your change or suggests a modification, it's easier for you to understand what's the intention behind it if you know the coding style of the reviewer. So in a pair, you sort of get a shared understanding on how to implement things and how not. And in a review, this shared understanding will come back to you and it will reflect the changes you have done to the code. So it really makes sense to know your teammates, and the best thing to learn knowing them is by developing together, by doing pair programming. Why would you want to do code reviews? Who does code reviews on a regular basis? Hands up. Okay, who does not? No shame. No shame. Here again, I would like to convince you at least to give it a try, because it is beneficial and it will make your code better, and it will also help you reduce bugs and risks and other issues and technical debt that later, when you have to fix it, will cost you more money and more time and more effort to fix than making the clean solution beforehand. So why do we want to do code reviews? We would like to put a second set of eyes on code. We want to force a developer to explain what the code does. If you are in pairing anyways, where you are in the discussion process, the code review is also an opportunity to ask questions like, what do you think here? What was your intention? Why did you implement it this way and not the other way? So code reviews force developers to explain the decisions they have made in their code. Code reviews are also an opportunity to find risky and wrong code beforehand. Maybe by a reviewer that has a deeper insight into a project, by someone who is more senior developer and maybe has seen similar issues before or knows about better solutions. And also to offer suggestions for quality improvement. And that offer of suggestions is important when talking about code reviews, because a lot of the things and the comments that happen in a review are only meant as suggestions. You don't have to incorporate them. It's totally fair if you don't take all the changes into consideration that are suggested in a review. But if there are critical issues or you have written factually wrong code, then it is a must to fix it. Same with that explanation portion. In a code review, you can take time to think about consequences of a change. Sometimes in the large project that is multiple years old already, you don't have the overview, maybe when changing a particular line, what side effects this might cause in very different areas of the project. And just by putting a second set of eyes, or maybe a third or fourth set of eyes on the change, this dramatically increases the chance that this side effect may be spotted by someone who has deeper insight into the project. Yeah, code review is also nice for sharing knowledge, like learning new tricks and correcting bad habits. I have one example, the comment is in German, but I will explain it, that happened to me recently. When writing data providers for unit tests, you can write them as associative arrays, and the array keys can be used as an explanation for what you are testing. And that was the guy who did the review wrote like, hey, I didn't know that you can theoretically do the documentation of the data provider in the array keys. So hey, I've learned something new. So this is just one small example. By doing code reviews, you might stumble upon ways to do things you never thought of or you never heard of. And that's quite convenient. You even don't have to tell others that you have learned something new. Just incorporate it into your habit and you are good. But yeah, this is important for sharing knowledge in a team. Code reviews when? That's something you can heavily discuss in your team, in your company, in your project. There are two ways to do reviews, and pre-commit and post-commit is when looking at the master branch. So you can either review pre-commit, which means you work on a feature or topic branch, and the code will be merged only when the review is done. So the risk of getting completely wrong code into master is dramatically reduced. The downside is the review is blocking. So without the review being done, the code may not be going to master, and this blocks the further progress of the ticket or user story you are working on. It can't be tested when it's not merged to master. So if you are in a rush at the end of the sprint, people tend to start pushing code review like, hey, do your reviews, I want my code to be merged. So there is a risk of stress on that review process. Benefit is like, if there are changes that need to be done as outcome of the review, you can squash all these into one single commit and have the feature as one commit merged into master. So it gives you a cleaner commit history. The other way is like doing a post-commit. You push your changes to master and create a code review, and when others have time, they will do the review. Downside, you can technically push any crap you're doing into master. That can break the entire system. Can happen. You might need additional commits to fix that, so that leads to a pretty strange commit history. Like you have your push to master, then you have different other commits, and then someone, here comes your fix outcome of code review commit. So you have issues like seeing these two commits together with the other changes in between. And you also have the risk of potentially ignoring the review outcome. So my code is already in master, why should I care about that code review? It could also happen to you if you have that kind of developers, the watch the master developers. Benefit is that it's asynchronous, so it's not blocking the progress of moving the story forward and getting it tested. How to do that? That's independent of when you do it. You should agree as a team on what kind of commits require a review. You might agree that code that has been written by a pair must not be reviewed, or that setting a TypoScript constant from 1 to 0 does not require a code review. You have to agree on review criteria. We will take a look at that later. And you may also think about how many reviewers are required. In one project, for example, we had the requirement that front-end changes have to be reviewed by at least one front-end developer. Because it makes not much sense if a back-end developer reviews a CSS change. I think that can look good to me and still be completely messing up this page. So you may also agree on that, like, hey, I need 2 reviews and one of them has to be by front-end developer, otherwise the review is not done. It's important that you try to find and eliminate as many defects as possible. So the review is impersonal and only about the particular code. So don't try to be kind to the other developers and say like, oh, that's only a small mistake, I would not, maybe, no. Just if it is a defect, you have to point it out in the code review. And the other developer is told to not take this personal. A few words more on that also later. And as I already mentioned, not all suggested changes have to be incorporated, but we will see in a second that there are categories of defects that have to be addressed. So, how to do this? Smaller commits lead to more manageable code reviews. If you have a large commit with 600 files changed, and I show you that this happens in practice, it's maybe difficult to review. If you have to sit down for 2 hours to do a code review, that maybe not the best idea. Also, what I like to do is like doing small step commits, and with our code review tool you can browse through these steps, and so you can either watch the entire feature committed or walk through the steps and follow maybe my thinking process by doing this in smaller chunks. You have to clearly outline what the actual intended change was meant to be. Otherwise, the reviewer might have issues like understanding what the hell is he doing, why is he doing that. It helps if there is a clear outline of the objective of what needs to be done. Regarding optional and not optional comments and reviews, people suggest using comment tiers, like a suggestion, you might want to use general utility here instead of whatever. Disagreement, like you should validate input before using it or whatever, and the defect, like you must not access the database directly. And depending on the severity of these tiers, you are either asked to incorporate the change, otherwise your ticket won't move on, or like it's suggestion, but maybe you can consider that somewhere later, but it has not to be changed now. And regarding code reviews, take your time. Faster is not better. It's not helpful if you review a large change in 2 minutes, like, oh, looks good to me. And that's also the tendency. The bigger the review gets, the more often other developers just say like, yeah, looks good for me. And if you have a three-line change, you get a discussion of 8 or 10 comments because the change is smaller and people are more able to think into the consequences of the change and to maybe spot errors in there. So smaller commits make it easier, and then with a decent amount of time, look onto the change and see if you can find any difficulties or errors in there. Yeah, best practices, don't take it personal. Code reviews are highly subjective. We had this in another team where a freelancer joined, and with every review he got a high amount of comments, and he was like really pissed then. Someone like, you don't like me, you don't like my code. No, we like you. It's okay, but the code doesn't match our quality measures we have. And also, like, code reviews are not there to train other developers. If you spot someone that's not on par with the team, don't try to teach him coding with code reviews. That doesn't work, and that really only leads to bad moods on all sides of the team. It's better than to take him at his hand and pair up or whatever and get him on par skill-wise, but don't do that in code reviews. As I mentioned, also don't push reviews. That is really annoying. If you are working and in your chat application or whatever team channel, people start pushing like, hey, can you do your review? I want to get my code merged. That's also not good. Maybe address this in your team stand-up. Look at the review board or whatever and see to get that done. Don't use metrics to single out developers. That's also, it's him again, 12 defects. Oh, God. Usually the number of defects is related to the complexity of the change, not to the skills of the developer. And yeah, a code review is not a tool for telling if someone is a good or a bad or not so good developer. So don't use that metrics. And also, as a reviewer, don't try to substitute the code you are reviewing with your implementation because you are the master and know better how to do this. Just review the change and see if it is according to the standards you have defined, but don't try to push your own implementation into the code instead. I have an example for a code review checklist because I mentioned earlier, like, you have to agree on what criteria have to be checked in a review. So what you could look for, and you have to agree with that on a team level, you could check for obvious errors, risks, and incompatibilities with your application. Code style is also always a good idea. I'm a bit of the code style Nazi in our team. You can do this automatically with code sniffer and so on, but it doesn't help, or it doesn't hurt if you also take a look on that. But you should not be nitpicking every missing white space or whatever. That can also be annoying. Yeah, you can check that the code follows the best practice of team and community. we had this in the talk before, like people are not using general utility for generating cache files. This is something you can spot in the code review, like, hey, there is a general utility for that, use it. I also like to check test coverage, not as in a tool that checks like if every line of code is covered by unit tests, but rather checking if edge cases are covered. If you are using data providers for tests with multiple scenarios, are only good scenarios in there, or also critical scenarios, edge cases tested. This is something you can look for in a code review. And then the obvious pattern catalog, like are there code smells, don't repeat yourself, keep it simple, and you aren't going to need it, so only implement what you are needing right now. You can just agree on that on team level. So again, from Brandon Savage, code reviews are opportunities to spot things in the code that are dangerous, bad, mistaken, or wrong, and to offer quality improvement suggestions. Not more, not less. And now the tales from the reviews. We did 1,092 code reviews in roughly 80 months. That's 14 a week, or almost 3 a day. The biggest review contained too many files. That was not possible to review at all. The most controversial review led to 144 comments, and it would have been better to pull that back and get together as a team and just discuss again, because I think we had a different understanding on what to do and how to implement it, and this was a real pain in the ass and took weeks to get done. So, but we are learning that Agile stuff, right? When looking at these 18 months of code reviews, and that's the amount of open reviews over time, you can see 2 peaks. We started in the phase where we're preparing the T3EE16 relaunch, so that's some years ago already the project started. So we have a peak here and then got back to sort of normal operations, and then it started accumulating again for the e-commerce launch. And then we went to normal operations without implementing big features anymore. So you can nicely spot the peaks, the highs and lows of your project also in your review tool. The comment volume over time, it is that code reviews will make teams harmonize their coding style and also come to a shared understanding of how to implement things. And we sort of also had this. The red things are the critical issues that have to be addressed, and blue are general comments. Even though you don't see a total decrease in the volume, at least you see that the red parts get smaller over time. So when here we have lots of red, and this decreases at the end. So this is sort of proven that we also have improved our style or harmonized our style as a team. Defect ranking over time, that's maybe also interesting, that has remained constant. The major, we worked with a tool where you can mark a comment either as a defect or leave it as a comment. And if it's a defect, classify in major and minor. And at some point we just decided like, we don't do that minor classification anymore, we just leave it unclassified. So the yellow and the blue can be treated as the same, and only the red is the major defects that had to be addressed. And this remains constant over time, but this is also fair because you are always developing new features, playing around with new technologies, so there are always, it's fair to have critical defects. As mentioned, the critical defects are not about the skills of the developers, but about the complexity of the application. So this is really fair to have a constant line in there. Yeah, coming to the end. You should agree on guidelines and standards in your team. Don't take mine, agree on yours. Program in pairs as often as possible, even though if it is exhausting, I know that, but I really enjoy doing this. and keep your commits and reviews small to ease the review process and also to help others understand your changes better. And from Martin Fowler, any stupid can write a program that computer understands, but only good programmers write code that humans understand. And this is what counts when pairing up and doing code reviews. Thank you. Yeah, feel free to follow me on Twitter and say hi if you're in Wiesbaden. And now, time for questions.
I was wondering when you mentioned about pair programming. I'm not a programmer myself, but you do have this phenomenon that people get into the flow of working.
Yeah.
How does that pairing work with or against the flow?
Yeah, I get your point. In fact, pretty well, because the team gets in the flow, and then it does not really matter who is like the driver or the navigator, because both are in the process, and it's just like who does what, and you swap the roles intuitively. But it is really possible that the team gets into the flow. Sometimes even ignores the timer because they are like, now we have to finish that, that's only fair, and then maybe swap afterwards and start over. But yeah, it is possible that also the pair that gets into the flow.
Cool, okay.
Do you have some tool or something, or what is the workflow? How you do the code reviews actually?
We are using a tool that's at Lächeln Crucible for code reviews, but you can also, like, GitHub has this built in now, and with one of the, some months ago, this even evolved from the possibilities you can do. You can mark comments as blocking now for the merge of the pull request and so on. So yeah, pick your tool. But as I said, we are using Crucible for quite some time and are happy with it. Yeah?
How often do you change your pairs? How big is your team? And maybe it's 8 persons or so. Do you change them?
Yeah. Yeah. This we are 4 backend and 1 frontend developer, and yeah, we change with every. At least with every user story we are working on, but sometimes if we can break this down in smaller tasks, even on task level. Yeah, this is really important, that not always the same people sit together. I think that we are done. Thank you for listening.